Okay, so this worksheet, again, let's go through this together. I will post these solutions as well. Okay. Well, let me just see. Oh, I got to share the solutions. Oh, nope, this one, that's right. Here it is. Okay, so again, here, right, so these are the solutions to the, what do you call it, the worksheet. Okay. Okay, so let me, yeah, this is fine. Okay, so again, here for the first one, we have x squared minus 17x plus 30. And again, we want two integers, right, whose product is 30 and whose sum has to be negative 17. So again, the product has to be the constant term here, the 30, and the sum has to be negative 17. Remember, you want to include the negative sign. Okay, you have to include that. And as I have here, hopefully you use the numbers negative 15 and 2. Because those numbers basically work. And so we get this. I mean, I didn't show the GCF was 1, but hopefully you can see that, right? I mean, we have a non-zero constant term, so you can't factor out x at all. The coefficient of x squared is 1, so you can't factor out really any numbers, so the GCF would have to be 1. Now, you can't factor out a number from each term. You can't factor out x from each term, at least x, that is. So the GCF is 1. For the second one, x squared plus 2x plus 3, right? Here, again, you want two integers whose product is 3, right? And the sum has to be 2. And I made a mistake, didn't I? Yeah, there's something wrong there, isn't there?
Yeah, I was gonna say it can't be x plus 2 and x plus 1. It would have to be x plus 3, x minus 1, because you're doing multiples of 3, so it would be 3 and 1.
How did I, man, okay, thank you. Yeah, I don't know. Yeah, it has to be 3 and, wait, you said negative 1?
It was x plus 3 and x minus 1.
That's not going to work either. The product has to be 3. Right?
Well, it has to be 2. It's if you have 3x.
No, the sum has to be 2. The product has to be 3.
But you have 3 and a 1.
Yeah, but that sum isn't 2. I don't think it can be factored. Let me skip that. I'll come back to it and I'll fix it in the solutions, okay? So let me just skip that one. Okay? Okay. Someone else had a question, or?
Sorry, I was just gonna say, yeah, it's not factorable.
Yeah, I don't think it is. Yeah. Okay. I'll double check it just to be on the safe side. So. Okay. All right. So what about the next one? X squared minus 4x plus 24. That also actually cannot be factored, right? Because you want two numbers whose product is 24, but the sum you want it to be negative 4. I mean, I listed them, and like 12 and 2, right? That's not going to work, right? Because the sum is 14. Negative 12 and negative 2 don't work either. That's negative 14. 6 and 4 doesn't work. Negative 6 and negative 4 doesn't work. 8 and 3 doesn't work. Negative 8, negative 3. So basically, you have no two numbers that are going to work. And so because of that, this polynomial also cannot be factored. Number 3. Does that make sense to everyone? Okay. All right, so that was number 3. Okay. Okay, let me get rid of this one. That's there. Okay. So for number 4, notice here you can factor out the GCF, right? Right? You can see that the smallest power of x, excuse me, the smallest exponent of x, as I have written, is 2. Okay? And you also need to get the greatest common factor of 3, 42, and 72. Hopefully, even without the solutions, you saw that it was 3. Okay. I mean, I didn't list the factors of each one. The only factors, remember, of 3 are 1 and 3. And 3 is a factor of 42 and 72. So 3 is the greatest common factor. 3x squared, excuse me, is the GCF. And we can factor it out. And remember, this is how you factor it out. You have to divide. Okay? You have to divide. Right? You divide each term by 3x squared because you want to get what's left over. I know some people ask me, what do you do with the 3x squared? Just leave it in front. Because now we have to handle this stuff here. The x squared plus 14x plus 24. Okay, so how do we factor that? Well, here, right, we want 2 numbers, right, whose product is 24, whose sum is 14. So what numbers do that? Well, you can see what's written there already, but 12 and 2. 12 and 2 are going to pull that off. Okay. Okay, I hope that makes sense. All right. 12 and 2. So now if we put them in, then all together, we put it in here, this is the factorization, right? We have the GCF in front. We have x plus 12 times x plus 2. So that's the factorization of it. Okay? All right. You know, so again, here you can see that sometimes you have to use more than one technique. Any questions on that? Okay. And for, I think, the last one, no, excuse me, the second to last one, this one here, again, right away, you should be able to see that the GCF is not going to be 1. How do we see that? Well, every term has an x in it, right? That is, the smallest exponent of x is not 0, it's 3. So every term has, so we can factor out the GCF. The smallest exponent of x is 3. And if you look at 5, 5 is one of those numbers whose only factors are 1 and itself. Such numbers are actually said to be prime, but they have to be greater than 1 also. So 5 is actually prime. But notice 5 is a factor of 50 and 120. Right? So the only factors of 5 are 1 and 5. Since 5 is a factor of 50 and 120, that tells you 5 is the greatest common factor of the coefficients. I hope that makes sense to everyone. I mean, I didn't list the factors out, but you would see 5 is the greatest common factor of the coefficients. So basically 5x cubed is the GCF. So just like the other example, what we have to do is factor it out. But you have to divide to see what's left over. Right? And that's what I'm doing. Right? When you divide, remember, you divide into each term. Okay? That's what we do. And we're left with 5x cubed times x squared plus 10x plus 24. Now, are we done? Well, we have to know if x squared plus 10x plus 24, if that can be factored, and it can. I mean, it's right there in front of us, but you need two numbers, right? We have a trinomial here where the leading coefficient's 1, and we have 3 terms, it's degree 2, so let's try that method that we've been using. We want two numbers whose product is 24, the sum is 10, well, 6 and 4, right? I mean, if you go, well, you really can't see it, but if you tried other things like 8 and 3, that wouldn't work because 8 plus 3 is 11. Or 12 and 2 wouldn't work because the sum is 14. But 6 and 4 do work, right? The sum is 10. Not 14, it should be 10. Okay. So again, now what do? We put it in, right? We have x squared plus 10x plus 24 is x plus 6 times x plus 4. So now we put it in to the answer, right? We get 5x cubed times x plus 6 times x plus 4. And the last one, real quickly, the GCF is actually x. You can see the smallest exponent of x is 1. And we have a coefficient of 1. So in other words, the greatest common factor of the coefficients is 1. And the smallest exponent of x is 1. So the GCF is just x. And for this one, x squared plus 25x plus 24, hopefully you can see that 24 and 1 are going to do it. See if I can get down here. Oh, it's not there. Okay. But anyway, x squared plus 25x plus 24, that's going to be the solution. Okay, thought I wrote it out. Well, we're out of time anyway, so let's stop here. Oh, man. All right.